Electron from valence shell, exactly. Right, very good. Because if you start removing the electron, it should be removed from the outermost shell. Got it?
Yes.
Got it. So that we discussed, and we were discussing the applications of ionization energies. Okay. So basically, the applications of ionization energies basically, suppose if the ionization energy is low, that means the element will show metallic character, right? It will be
Yes.
it will be metal because metals can lose electrons. Okay, so let me write it. Okay, metallic character and green. Okay.
Okay, sir.
Let's do one question. So these are the three elements. Okay, sodium, magnesium, silicon, and their ionization energies are 496. Magnesium is 737. Silicon is 786. Got it. And this is the 11th element, that is the 12th element, and this is the 14th element.
Okay, sir.
One element is missing. Which one?
13th element.
13th element is aluminum.
Oh, aluminum.
Okay. So predict whether the first ionization enthalpy of aluminum will be close to 575 or 760.
So 760.
So this is sodium, right? Sodium,
Yes, sir.
magnesium, and they are in the same period left to right. So what happens when you move left to right
Uh,
in a period?
uh,
Ionization energy increases, right? Because we have seen
yes.
the last class that the electrons will be added to the same outermost
The,
shell. Right?
yes, sir.
It's a clear. This is silicon.
Yes, sir.
I made a mistake. The size is going to decrease, and these are the valence electrons. Sodium is 11th element, 1, 2, 3. And if you try to suppose if you try to uh, write the electronic configuration, That is, I will write the short hand representation. What happens to the ionization energy left to right?
It's decreasing.
Yeah, it increases. Exactly. Why it
It has
increases?
increased.
Yeah. So what do you expect? What should be the order of the ionization energies of these four elements? There were certain exceptions. Okay.
Mm.
So exceptions were basically due to what? Exceptions were because of the stable electronic configuration. Got it?
Yes, sir.
So half filled and fully filled were having the ionization energy used were more than what was expected, right?
Yes, sir.
Is that clear? So
Yes, sir.
normally you expect it to be like this, okay? But you can see that we are having the fully filled S, right? S2. This is going to be more. Is it clear or not?
Yes, sir.
Okay. Because this is sodium, magnesium, okay. Then you have aluminium. In the this is from the third period. In the second period, we have seen the same thing happened for beryllium. Beryllium was more than boron. Got it?
Yes, sir.
Clear?
Yes, sir.
Okay. So basically, the magnesium should be higher than aluminum because why? What's the reason?
Mm.
Due to fully filled S,
Liquid balance.
right? So wherever you have fully filled or half filled
Yes,
subshell, it happened in nitrogen also. Yeah. Where the S subshell was having 3p, right? 3p having
yes, sir.
one electron. Got it? So
Yes,
this
sir.
I hope is clear to you. Okay. Next is this is about the ionization energy, and let me talk about the next property, electron gain enthalpy. Okay, what it means. What do you mean by electron gain enthalpy? What the name suggests.
The increase in electrons.
Hmm. Suppose ionization energy is about the removal of electron. So how much energy is needed to pull out the electron? Got it?
Yes, sir.
Is it clear or not?
Yes, sir.
So, and this electron gain enthalpy is about gaining electrons. Is that clear?
Mm. Yes, sir.
So what is the enthalpy change or the energy change when an isolated atom in the gaseous state, okay, accepts an electron?
Mm.
Enthalpy or energy change when an isolated atom So why do you think that some atom should accept an electron?
Mm, maybe to stabilize it.
Yes, to attain stable electronic configuration, right? And
Yes, sir.
which element do you feel are the metals or the non-metals have tendency to accept electrons? Metals or non-metals?
Mm,
Metals were electropositive and they were having the tendency to lose electrons. Okay, mostly they are
agree.
non-metals. Okay. So basically,
Mm,
suppose if you take gaseous atom and if you try to give electron to it, it will become X minus gaseous, right? Is it clear?
yes,
So
yes, sir.
there will be some energy change happening, and that energy change will be represented by electron gain and enthalpy. Delta Eg, okay, electron gain enthalpy. H is a sign for enthalpy change or the heat change. Got it?
Yes, sir.
So actually, for most of the elements, the heat will be released. For many elements.
Mm,
Got it?
yes,
So it, theoretically, it can be exothermic or endothermic, but for many elements, heat will be released. So can you explain me why heat will be released?
mm, exothermic. So,
And what will be the sign for delta H for many elements?
mm,
What is going to be the sign for the delta H? Heat is lost. Okay, that means what? Negative. Is it clear or not? Lost.
yes, sir.
Heat is released. Delta H Eg is going to be negative. Why is it so?
Because it will be released from any of the elements, so it's negative.
Because the electron will get attracted, okay, towards the
Yes, sir.
nucleus, that new electron from outside, and that is going to release the energy. Is it clear?
Yeah, okay, sir. Yes,
So
sir.
energy is going to get released when you have because of the nuclear charge. Because of the nuclear charge, that it has its own electron. Yes, but along with its own electron, it is going to attract the outer electron from the outer
Mm,
environment. So that electron will get attracted towards the nucleus. Okay, for example, suppose if you take chlorine, how many electron it is having in the valence shell? Chlorine is a ninth element, so 2 and 7. Got it? Valence electrons
Yes.
are, and suppose if one electron get added further, it will become what? F minus. Is it
Yes.
clear or not?
Yes, sir.
It is going to become F minus. Why it has become F minus?
Because it took the electron.
I took the electron, and will it have a higher tendency to accept the electron, or will not? Will it not have any tendency to accept the electron?
It will accept it to
Yeah, it will
stabilize
have
it.
a higher tendency because it will become stabilized. That octet get completed. Got it?
Yes.
Is it clear?
Yes, sir.
Similarly, if you look at Cl, okay. So Cl is the 17th element.
Mm.
And that
2,
will
8,
also,
7.
yeah, it has 17th element mean 10, 10, 7. Okay. So 2,
Mm.
8, and 7. Okay, it is the chlorine. F was from second period, this is from the third period.
Yes, sir.
And it want to accept electron, it want to stabilize itself. So it will become Cl minus. Got it?
Yes.
2, 8, 8. Look, octet is completed. Okay. Energy will be released.
Mm.
Okay. What will be the sign for delta H?
Negative.
Negative. Where do you expect the more energy to be released?
Outermost. I don't.
Which element will release more energy?
Mm.
Wherever the one which will attract the electron more strongly is going to release more energy. Notice? Are
Mm.
you getting the point? The one
Yes,
who is
sir.
causing more attract. Okay. So ideally the chlorine should give more energy, but as per the size, it has smaller size, so it should attract more the outer electron more strongly towards itself, and
Okay, sir.
it should release energy. The F chlorine also releases energy, but chlorine being bigger, it releases more energy. Why?
Mm.
So first of all, you should remember
Mm.
third pair elements have higher negative electron gain enthalpy, means it is more released. Okay, than the second one.
The more the period, the higher it is.
More they release more energy. Means okay,
Okay, sir.
because the electron can get accommodated more easily because of their bigger size, and they cause lesser
Okay.
repulsion to the incoming electron. Smaller atom,
Mm.
less space, more repulsions are there, so that electron gets into the atom with difficulty. Okay. So
Yes,
third period elements have higher negative electron gain enthalpy, okay, as compared to second period elements. Higher negative electron gain enthalpy means more exothermic electron gain.
mm,
Okay,
yes, sir. It's clear.
because of the bigger size.
Okay, sir.
Lesser repulsion to the incoming electron. That incoming new electron can get easily accommodated bigger shell. Okay, because of that.
Mm,
But not every element want to accept electrons.
mm.
Okay, why? There are certain elements which do not want to accept electrons.
They are
Are you
already
getting it?
stable.
Hmm.
Mm.
What which elements will not want to accept electron?
The
Any
noble gases.
noble gases exactly. Why?
They are already stabilized.
Yes, they do not have empty space. Their octet is already completed. They are already stabilized. So as their octet is complete, so addition of the new electron is going to be difficult, right?
Yes, sir.
Is their octet or the I should and the shell or the subshell. Okay, P subshell is completed because they have 8 electrons. So addition of new electron is going to be difficult. Is it clear? And this
Yes, sir.
results into positive electron gain enthalpy. Is it clear?
Yes, sir.
Sorry. So positive electron gain enthalpy because uh, as you can see is the electron need to be pushed. Okay, the shell is already completed, so it will not want any electron. So if the atom
Mm.
doesn't want any electron, you need to push it, you need to give energy, it will not release. Okay. The noble gases will have positive electron gain enthalpy, and not only noble gases, all the other elements which have fully filled shell or half filled shell, okay, they will exhibit the. For example, the other exception is your nitrogen. So can you tell me what is the electronic configuration of nitrogen?
Mm, 2, 5.
Helium, suppose if you want to give the electron, it will become He minus. Okay. What is the electronic configuration? 1s square. So 1s can have only 2 electrons, it is completed. Okay. And 1s square, 2s1. So new shell need to be created. Okay. This is going to be cause more amount of energy. Got it?
Yes, sir.
Same is the case with the nitrogen also. That will also have a half-filled shell. So that will require more energy.
Mm.
But as you move from left to right in a period, how the electrons gain enthalpy get affected? It become more negative. Got it? Because the effective nuclear charge increases, size decreases normally. Okay. Non-metallic character increases. But this is more negative, is not regular. We have to be very careful. For example, noble gases doesn't have negative value. They will have positive value. Okay. Nitrogen will have positive value. Okay, because their shell is either if it is complete or half filled, then it is not going to accept the electrons. And if it doesn't want to accept the electron, okay, will it will be positive value. Okay. So can you compare the electron gain enthalpy?
Your voice is breaking.
My voice is breaking. Okay, just a second. Am I audible now? Nabila, am I audible? Let me stop the camera.
Yes, sir. It's still breaking.
Yeah. Is it okay now? Am I audible?
Yes, sir.
Okay. So electron gain and enthalpy of compare the electron gain enthalpy of phosphorus, sulfur, chlorine and fluorine. So where are they? Fluorine is the halogen. Fluorine is also the halogen. Phosphorus is below. So you have them like this: nitrogen, oxygen, and fluorine. These are the three elements from the second period. And from the third period below nitrogen, you have phosphorus, sulfur. Okay. So between these two, what I told just now,
Halogens.
the halogens and the second period and the third period show higher negative electron gain enthalpy. Cl is more negative than L, right?
Yes, sir.
Is it clear?
No.
Why? That we discussed.
Higher.
Hmm. Because of the size, actually F is too small. So the incoming electron feels more repulsive force. Is it clear or not?
Yes.
Then you have phosphorus and you have sulfur. Okay. So how can we compare the phosphorus and sulfur?
Their valence.
This is halogens are the most electronegative elements. Okay, they have high tendency. So then you have Cl is Cl, then you have sulfur and the phosphorus. Okay. These are the at the rightmost part of the periodic table. They will have high tendency to accept electrons. Okay. And among these,
Mm.
the chlorine is having high tendency, right? But as you we discussed one thing, left to right, what happens? Electron gain enthalpy becomes more negative. It becomes more and more negative. More negative means that it is going to be more amount of energy will be released. Okay. So chlorine and chlorine will be most negative. Then sulfur and phosphorus. Okay, sulfur and phosphorus will be less negative. So you have like this. Okay, and chlorine actually comes because of the small size, it causes more repulsion to the new electron. It is going to be like this. Is it clear?
Yes, sir.
Suppose if you want to add two electrons, can you tell me any element where you can want to add two electrons? Where you can add two electrons? Any element? Oxygen is there, right? What is the electronic configuration? Eighth element, so 2 and 6. And in order to complete the octet, 2 electrons can be added. Got it?
Yes, sir.
So when you have the 2 electrons, or you can write the overall equation also if you want. Okay. Overall equation is going to be if you add them up. Suppose if this is delta H1 and that is delta H2. Okay, just like the thermochemical equations, we know that the like algebraic equation, thermochemical equations also get added and subtracted. Okay. So whatever you are doing with the thermochemical equation, that you are going to do with their delta H value. So the delta H is going to be delta H1 plus delta H2. Got it?
Yes, sir.
So they are going to give you the values. Okay, and you can figure out the two values for nitrogen. There will be three values because nitrogen can accept 3 electrons, 3 more to complete it octet. Okay, you can add them up. First one, if it is positive, like first one is negative. Okay, and second one is positive. So you take the algebraic sum. Okay, whatever you get positive, negative, that will be the complete equation. Got it?
Yes, sir.
Next is your electronegativity. So what is the definition for electronegativity? electronegativity. It is represented by a symbol, Greek symbol, which look like X. Okay. It is known as chi. Okay. Let me write the chi. Right, looks like X, electronegativity. Let me first write the definition. So both look same. Electron gain enthalpy and electronegativity. They look very similar. But there is a difference. Okay. The difference is with respect to the atom, that electron gain enthalpy is actually about the gaining of electron by an atom. That you know. We have written the equations representing the acceptance of electron, right?
Yes.
Electronegativity is not about gaining the electron. It is about the pulling the electron from the bond. So let me write the definition. So it is the tendency of a bonded atom to attract the bonded electron pair towards itself. For example, if you take HCl, okay, what happens to HCl? The chlorine is more electronegative. So it will have tendency to pull the electrons. So this electron pair, okay, normally you might have done it in class 10 that electron pair actually normally it is formed by sharing, okay, the bonded electron, okay, and it is in the middle of two atoms in the bond. But what happens over here is the chlorine has more higher tendency to attract them. So instead of writing in the middle, I have shifted it towards the chlorine. Why?
Mm.
Because the chlorine has higher tendency to attract the bonded electron pair towards itself. Instead of saying whole thing, I can say it in a very few words. But chlorine is more electronegative. Are you getting my point? So what is
Yes.
electronegativity? Tell me.
Written, the where there is more negative charge, as
Yeah,
in
there is a tendency to attract the paired pair of electron towards itself. Okay, that is electronegativity.
okay, so
So if there is a bonded electron pair, it should go. It may not be in the exactly middle position. Okay, it may get pulled on one side. So it may get pulled towards one side, and which side is that? The side which has more electronegative atom connected. Got it? Is
yes,
it clear? More electrons.
yes,
So Cl is more electronegative. Got it? Delta negative, delta positive. More electronegative atom means higher tendency. So I should write electronegativity of fluorine. Why I have done this? Because why I have shifted the electron pair, and because the electron pair is shifted, so the Chlorine has acquired slight negative charge. So what is this? This written, this is delta negative. Okay, some partial, not complete -1, some partial negative charge. Okay, delta negative, and that is delta positive. A partial positive. It has happened because electronegativity of chlorine is more than the electron negativity of hydrogen. Is it clear?
Yes, sir.
So what do you know about the acid HCl? Have you seen it in the lab?
Yes, sir.
Okay, you might have used it in various experiments.
Yes, sir.
So how HCl breaks?
Hydrogen and chlorine.
It is an acid. When you put
Yes,
it in
sir.
water, it breaks apart.
Mm.
So I'm asking in what way it breaks? Is it H minus or Cl plus? H plus or Cl minus?
Mm.
So the breaking of a bond is governed by the electronegativity. Got it?
Mm.
So chlorine was more electronegative. Means it was having higher tendency to pull the electron. And if
Yes,
it
sir.
had higher tendency to pull the electron while breaking apart, that chlorine will take away both
Yes,
the electrons. Got it?
yes, sir.
So chlorine
So it's negative.
will be negative and H will be positive.
Yes, sir.
Got it? And that's
Yes.
how it happens when you put HCl in water. So why HCl is an acid? Because it releases H plus. Somebody may ask you why it releases H plus, why not H minus? No H minus. H plus. Because it is connected to a more electronegative atom. So while getting apart, the fluorine took away both the electrons of the itself and of the hydrogen. That's why the chlorine has acquired negative charge. Got it?
Yes, sir.
Clear?
Yes, sir.
So there are various methods to measure the electronegativity. So Pauling scale is the most common scale for measuring the electronegativity. Okay. So various scales, just like the measurement of the length. We can measure the length in centimeters, millimeter, inches. Okay, got it?
Yes, sir.
So there are various scales. Just this is just a number. Okay, to just like on the scale of 10, we try to rate something. Okay. If it scores 9 or 8, it is good. If it scores 2 or 3, it is bad. Right. So it is not a energy. Okay, like the electron gain enthalpy, it is not the energy released or absorbed, right? Not like ionization energy. It is just the relative tendency to to show that who has higher tendency to attract electron, bonded electron. Right? So there is no such unit like energy where like kilojoule per mole. That kind of units are not used at all. Got it?
Yes,
You
sir.
just assign a scale. It is just like a rating. Okay, and you give it some numbers. These numbers, basically, for example, if you take the Pauling scale, basically this is F is having electronegativity of 4, where
Yes, sir.
F is having electronegativity of 4. That is the most electronegative element, right? And
Mm.
hydrogen is having electronegativity of 2.1, right? Is it clear?
Yeah. Yes, sir.
So suppose if you are having uh, let's say uh, HF bond, right? So F being more electronegative will carry negative charge and H will carry delta positive charge.